Hi students, good evening everyone. Okay, class is live now. As I said, I am going to take application of derivatives, and in that I take maximum and minimum. Okay, so when the maximum and when the minimum for the function is to exist, that we have to check. Okay, in this particular session we shall discuss about maxima and minima of the given function. Clear? Okay, so quickly tell all your friends to join the class so that we can go on solving the problems. In this particular session I am going to take the problems on maximum and minimum of the given function. Okay, so here you can just see I am going to solve problems one by one. Is the minimum value of in this particular problem I am going to take the minimum value of the given function, that is x minus a into x minus b. Here I am going to solve the minimum value of x minus a into x minus b is a minus b whole square divided by 4, 0. Fourth option is minus of a minus b whole square divided by 4. My dear students, here you must know what is local minimum and what is local maximum, and what are the steps to solve local minimum as well as local maximum, that you must know. So for that you just remember the formulas of local maximum and local minimum and the steps that we were solving in your finding your local maximum and local minimum values. Okay, so here you have to calculate first derivative, and next you have to calculate second derivative, and then you have to check the second derivative is positive or negative. So according to that you have to go through it is going to have a maximum or minimum value for the given function. Okay, so first you just say write the given function as f of x. I will write the given function as f of x equal to x minus a into x minus b. So you simplify x minus a into x minus b, you are going to get x square minus a plus b plus ab. This is the multiplication of x minus a and x minus b. If I multiply these two terms, I am going to get x square minus of a plus b into x plus ab. Clear? So after this you can just say I will differentiate the given function. So if I differentiate the given function, as you all know, the differentiation of x square is 2x and a plus b is as it is, and the differentiation of x is 1. So a plus b into 1 is a plus b. Here ab is the constant term. If you differentiate ab, which is the constant term, you see if you differentiate this, which is the constant term, it will become 0. Okay, so here the differentiation of x is 1. 1 into a plus b is a plus b, and the differentiation of x square is 2x, so that will be 2x. Clear? So now you have f dash of x equal to 2x minus of a plus b. Clear? Again, after getting first derivative, you calculate the second derivative, so that will be f double dash of x. So f double dash of x will be what? Here this is constant term, so it will become 0, and here you can see 2x. If I differentiate 2x, you are going to get only 2, which is greater than 0. Okay, so that means here the second order derivative is greater than 0. So quickly remember, if the second order derivative is greater than 0, what we tell? F has a maximum or minimum at f dash of x equal to 0. So this for f to be having maximum or minimum, you have to equate this term to 0. Okay. So after that, you just see, if I equate that term to 0, x will be equal to a plus b divided by 2. X will be equal to a plus b divided by 2. So now the minimum value for the given function f of x, the minimum value for the given function f of x will be what? F of a plus b divided by 2. Okay. So f of a plus b divided by 2 means in the place of x, you have to write a plus b divided by 2. In the place of x, you write a plus b divided by 2. Okay. So here you just see, in the place of x, you have to write a plus b divided by 2. The place of x, you have to write a plus b divided by 2, and you just simplify it. You are going to get b minus a divided by 2, a minus b divided by 2. So if I multiply these two, it will be minus of a minus b whole square divided by 4. Okay. So here, this is important. Okay. Why it is important? If f double dash of x is greater than 0, your minimum value is going to exist. So quickly you remember the techniques of solving local maximum and local minimum. If the second order derivative is greater than 0, just see, if the second order derivative is greater than 0, minimum value exists. If f double dash of x is lesser than 0, then maximum exists. If f double dash of x is greater than 0, then minimum exists. Okay, that's why you have to be very careful. Just you take the given function, you differentiate once, so you will get f dash of x. After you getting the f dash of x, once you get the f dash of x, what you do? You equate it to 0 and find the values of x. Okay, first step is calculate f dash of x. Second one is equate f dash of x equal to 0. Here you have to calculate f double dash of x. So once you get the x values, you have to substitute in the f of x. Okay, so these are the steps. Please remember, calculate f dash of x, also calculate f dash of x, and equate f dash of x equal to 0. You have to find the x value, and then you have to put the x value in f of x. So that will be your local maximum or local minimum value. Okay. So these are the steps to find local maximum and local minimum. So here you can just see, for the given problem, you have minus of a minus b whole square divided by 4. Is minus of a minus b whole square divided by 4 is your required answer. Okay. So quickly give me thumbs if you have understood this, so that I can understand you have understood this problem. And if you have any doubts, you can ask, no worries. Otherwise, quickly I can go for the next problem. There is another one alternative method. You can just see the alternative method to having the minimum value is for ax square plus bx plus c. For only ax square bx plus c, the minimum value is given by this shortcut formula. Okay. So you have to remember this. Clear? The shortcut formula is 4ac minus b square divided by 4a. Just see here. You have x square minus of a plus b plus ab. In the place of a, you have 1. In the place of b, you have minus of a plus b. In the place of c, you have ab. Okay. That you have to substitute in the place of a, c, b and a. You can use this as the shortcut formula for finding. See that a value is 1, b value is a plus b, c value is ab. You have to put them in the required places and you will get your required result, that is minus of a minus b whole square divided by 4. Minus of a minus b whole square divided by 4. Clear? Okay, you can use this method also, no problem. So now quickly we can go for the second problem, that is the maximum value of f of x equal to x into log x whole square occurs at x equal to e, x equal to 1 by e, x equal to e square, or x equal to 1 by e square. So they are asking the maximum value. So already you know the steps. First you have to calculate f dash of x. Next you have to calculate f double dash of x. You have to equate f dash of x equal to 0 and find the value of x and put it in f of x. Okay. You just see. First you take the given function f of x. Next you calculate f dash of x. What is f dash of x? This is u, this is v. Okay. So apply u into v formula, that is u into dv by dx plus v into du by dx. Clear? So you calculate it. U is x, v is log x whole square. To differentiate this, it will be 2 times of log x. The differentiation of log x is 1 by x plus log x whole square you write as it is. Differentiation of x is 1. Okay. So now you have x into 2 times of log x into 1 by x plus log x whole square into 1. So now from this you can just see you got f dash of x. Okay. Quickly differentiate it once more time. Okay, that is f double dash of x. Once you go for f double dash of x, it will be 2 times into 1 by x, and again you have to differentiate log x whole square, so that will be 2 times of log x into 1 by x. On the same way, you calculate f dash of x equal to 0. That means just see log x is common. Log x of 2 plus log x equal to 0. Okay, so that will be, to just take log x equal to 0 or log x plus 2 equal to 0. Clear? So now if log x equal to 0, it gives you x to the power of 0. Sorry, x equal to e to the power of 0. E to the power of 0 is 1. Okay. On the same way, you can take log x equal to minus 2. That will be x equal to e to the power of minus 2. Therefore, x equal to 1 or x equal to e to the power of minus 2 is going to be your answer. Okay. So, and you can just see that the maximum value exists at x equal to 1 by e square. The maximum value exists at x equal to 1 by e square. Okay. So whenever you put x equal to 1 in the f of x, what you are going to get? Log 1 is 0. Therefore, the complete term becomes 0. And whenever you put 1 by e square, you can just see you will get the maximum value for f of x. On the same way, f double dash of x, you see f double dash of x is going to be lesser than 0 for x equal to e to the power of minus 2. X equal to e to the power of minus 2. Okay. So therefore, option 4 is going to be your answer. Option 4 is going to be your answer. Okay. So you can just see that the maximum value of f of x equal to x into log x whole square occurs at x equal to 1 by e square. X equal to 1 by e square. Clear? Okay. So I think everyone have understood this. So that quickly I can go for the third problem. To see the third problem, it is if f of x equal to x to the power of 5 minus 5x raised to 4 plus 5x cube minus 10 has local maximum and minimum at x equal to p and x equal to q respectively, then p comma q is what they are asking. See this, they have given the function. They have given the function, that is f of x equal to, they have given the function f of x equal to x raised to 5 minus 5x raised to 4 plus 5x cube minus 10 as local maximum and minimum at x equal to p and x equal to q respectively, then p comma q is what they are asking. Okay, so see the options. Here the options are 0 comma 1, 1 comma 3, and third option is 1 comma 0. Fourth option is none of this. Okay, so quickly you can just go through it. The given function f of x equal to x raised to 5 minus 5x raised to 4 plus 5x cube minus 10. Just differentiate it. Once you differentiate this, it will be 5x raised to 4 minus 20x cube plus 15x square, and differentiation of minus 10 is 0. You differentiate the given function again, so that will be f double dash of x, that is 20x cube, because just see here, if you differentiate 5x raised to 4, it will be 20x cube. If you differentiate minus 20x cube, it will be 60x square, and if you differentiate 15x square, it will be 30x. Okay, now for the given function, we know that we have to take f dash of x equal to 0. So if I take f dash of x equal to 0, you just see here 5 is common, x square is common. I will take 5x square as common term. So if I take 5x square as common term from this, you just see x square will remain from the first term, 4x will be remaining from the second term, and 3 will be remaining in the third term. Clear? So 5x square into x square minus 4x plus 3 equal to 0. And in the next step, you can just see equate 5x square equal to 0 as well as x square minus 4x plus 3 equal to 0. By equating these two terms as 0, you get x equal to 0 as one term, and you just factorize x square minus 4x plus 3. You are going to get 1 and 3 for x values. You get 1 and 3 for x values. Clear? So now you can go for solving the double differentiation. Already you know the double differentiation term. You just check where it is lesser than 0. You just check where it is lesser than 0 for f double dash of x. Okay. So you put 0, it will complete term will become 0. You put 1, it will be 20 minus 60 plus 30. 20 plus 30 is 50. Therefore, you can just see that for f double dash of 1, it is minus 10 lesser than 0. That means here it exists with maximum because it is lesser than 0. Because here it is lesser than 0. Okay. So if it is lesser than 0, then the maximum is going to exist at x equal to 1. And you can also see that what is maximum, that will be by putting x value in f of x. Okay. Next, you can just see that if I put 3 in the f double dash of x, so it will be 90x. Okay. Therefore, at x equal to 3, again it is greater than 0. Therefore, you can just see that p value is 1. P value is 1. To find the q value, you have to put x in. You have to put x here. Okay. So 1. Here it is 1, here it is 1. You just calculate it. Minus 5 plus 5 will get cancelled, and you just see 1 and minus 10. It will be minus 9. Okay. So therefore, at p equal to 1, q will be equal to 3. Here, you can just see that local maximum exists at x equal to 1. Local maximum exists at x equal to 1 and local minimum exists at x equal to 3. So So if video is not clear, you just close the app and you again open it, so it will be very much clear. Okay. So you just see this problem once again. Just see this problem once again. They have given the f of x term. They have given the f of x term. Okay. What you have to do? What they are asking? They are asking local maximum and local minimum, where the local maximum and where the local minimum exist. Okay. So for what value of x local maximum and local minimum exist, they are asking. Okay. So here there is a given function f of x to differentiate once and if differentiate twice. If you differentiate once, differentiation of x raised to 5 is 5x raised to 4. If you differentiate minus 5x raised to 4, it will be minus 20x cube. If you differentiate 5x cube, it will be plus 15x square. If you differentiate this, it will be 0. Okay. So if you double differentiate this, the term of 5x raised to 4 will be 20x cube. This will be 60x square and this will be 30x. Okay. You got f dash of x. You got f double dash of x. Now equate f dash of x to 0. Equate f dash of x to 0. If I equate this f dash of x, that is 5x raised to 4 minus 20x cube plus 15x square to 0, you just see I will get 5x square as the common term from all this. 5x square I will take as the common term and the remaining terms are x square minus 4x plus 3. So 5x square equal to 0 means x equal to 0 and x square minus 4x plus 3, this term is equal to 0. So you get these two equations. X equal to 0 is one solution and you factorize this, you are going to get 1 and 3. If you factorize this, you are going to get 1 and 3. Okay. So once you get 1 and 3, once you get 0, 1, 3, you have to put it in f double dash of x. You have to put it in f double dash of x. See, if I put 0 here, this term becomes 0, this term becomes 0, this term becomes 0. So if all the terms becomes 0, I will say neither maximum nor minimum. I will say neither maximum nor minimum. Now put x equal to 1 here. If you put x equal to 1, you just see f double dash of 1 is going to be minus 10. F double dash of 1 is going to be minus 10 lesser than 0. If f double dash of 1 is minus 10 lesser than 0, then f of x is maximum at x equal to 1. That is nothing but p equal to 1. See this. I have given this order pair. Okay. So x is p. Another x is q. Clear? So first we got x value as 1. That is nothing but p. So I will write it here. The order pair. Next, this is not triple dash. This is double dash. This is f double dash. Okay. So f double dash of 3. That is the second term. If you put f double dash of 3, you will get 90, which is greater than 0. So therefore, here you can just say f of x is minimum at x equal to 3. F of x is minimum at x equal to 3. That implies q is equal to 3. Therefore, 1, 3 is your solution. Therefore, 1, 3 is your solution. Okay. So I think everyone have understood this. Quickly tell me so that I can go for the next problem. Clear? Okay. Let us go for the next problem, that is problem number 4. Okay. The problem number 4, you can just see that the sum of two numbers is k and their product is maximum. Then the numbers are what they are asking. Okay. the sum of two numbers is k and the product is maximum, then what are the two numbers they are asking? These are the four options. So first let us take the sum of two numbers, that is x plus y equal to k. Here they have given the sum of two numbers. So I will take x plus y as the sum of two numbers, that is going to be equal to k. So therefore x plus y equal to k. I will take the given condition. Next, let the product p be equal to x into y. Let the product p be equal to x into y. Okay. So now p will be equal to x into k minus x. So just to see this, I can simplify this as y equal to k minus x. Y equal to k minus x. Clear? So in the product, x value I will write as it is x, and y value I will write it as k minus x. I will write it as k minus x. So now if I differentiate the p, it will be k minus x, because here this is u, this is v, product rule. So k minus x as it is into 1, that is k minus x, plus x into minus 1. So here you can just see it is k minus 2x. Minus x will be minus 2x. If I differentiate again, that will be p double dash. If I get, k term becomes 0, minus x will be what? Minus 2x. If I differentiate this, you are going to get minus 2. Minus 2 is lesser than 0. Okay. Therefore, p double dash is lesser than 0. That means maximum exists. That is given in the problem. Maximum exists. Clear? So next you can just see, for p to be maximum, we have to take p dash equal to 0. That means k minus 2x equal to 0. K will be equal to 2x. X will be equal to k by 2. Okay. See here, x will be equal to k by 2. Once you get x value as k by 2, you can use it in equation 1, that is x plus y equal to k. If you use here x plus y equal to k, in the place of x you can use k by 2. So therefore y will be also equal to k by 2. K by 2 comma k by 2 will be your answer. Okay. So from this you can understand that the two terms are k by 2 comma k by 2. K by 2 comma k by 2. Clear? So I think everyone have understood this, that I can go for the problem number 5. Is option 1 is the correct answer. Option 1 is the correct answer for your given problem. Okay. Alternative method, you can just see x plus y equal to k xy maximum, then x equal to y equal to k by 2, no problem. Alternate method means we know that plus y equal to k, their product is maximum, means you can just say x and y must be equal. If these two terms are equal, only possible cases k by 2 plus k by 2. So like this, in quickly, that means you can use this shortcut method also. Okay, can use this shortcut method also. Here, very simple, because you have two numbers, the product must be maximum, means if I take any two numbers, they are equal, then the product is maximum. The product is maximum. Whenever two numbers are equal, then the product is going to be maximum. So therefore easily you can identify that k by 2 plus k by 2 will be equal to k. Therefore it is the required answer. Okay. So now I will go for the fifth problem. In the fifth problem, you can just see that f of x equal to e power x plus e power minus x. the stationary point. They are asking the stationary point of f of x. Here they are not asking local maximum and local minimum. They are asking stationary point of f of x equal to e raised to x plus e raised to minus x. Okay. Just see here. The differentiation of e raised to x is e raised to x. The differentiation of e to the power of minus x is minus e to the power of minus x. For f to be a stationary point, take f double dash of x equal to 0. F dash of x must be equal to 0. That means e raised to x minus e to the power of minus x must be equal to 0. Okay. That is nothing but, you can just see, if you solve this, you will get e raised to x equal to e to the power of minus x. Clear? So from this, if I solve this equation, you can just see that x equal to 0. Only this is possible at x equal to 0. Okay. So therefore, f of 0, that means here at x equal to 0, you have to identify e to the power of 0. E to the power of 0 is 1 plus 1. So that is 2. Therefore, stationary point at x equal to 0, comma f of 0. So x equal to 0 and f of 0 is how much? 2. This is your answer. That is 0, 2. So for stationary point, you have to take f dash of x equal to 0. Don't worry about f double dash of x. Don't worry about this. You just take f dash of x equal to 0. You equate it. Find the x value. Here x value is 0. If the x value is 0, then you can just see that if x is going to be 0, e to the power of 0 plus e to the power of 0 is 1. 1 plus 1 is 2. Therefore, 0, 2 will be your required answer. 0, 2 will be your required answer. Okay. I think everyone have understood this. Only thing is, stationary point means f dash of x must be equal to 0. This is important. Clear? You have to simplify this equation. And if you want to find stationary point, the stationary point is 0, 2. 0 is x value, 2 is f of x value. Okay. Here this is 0, f of 0. That will be the stationary point. 0, f of 0. Okay. Quickly you can just see that 0, 2 is your required answer. Okay. That is option 4. Option 4 is going to be the right answer. Clear? Okay. Quickly we can move for the 6th problem. And in the 6th problem you can read that they are asking the dimensions of a rectangle of maximum area with the perimeter 2p are. You just see the dimensions of a rectangle of maximum area. Of a rectangle of maximum area with perimeter 2p. They are asking this term, maximum area whenever the perimeter is 2p. Okay. So here we can go through this solution, that is, let the dimensions of a rectangle be x, y. Let the dimensions of the rectangle be x, y with perimeter 2p. So see here, this is x and this is y. That is, x is length, y is breadth. Now the perimeter is 2p. Perimeter formula is what? 2 times of x plus y. This is going to be the perimeter of rectangle. Clear? That means you can just see the perimeter of the rectangle is 2 times of x plus y, but the perimeter of the rectangle is given by what? 2p. The p value is going to be equal to 2p. Clear? So 2p is equal to 2x plus 2y. 2p is equal to 2x plus 2y. So now 2 is common, and to take common and cancel it, that will be x plus y equal to p. Now you differentiate the p. Before that, you just see area. Area means length into breadth, that is x into y, is maximum when x equal to y. Maximum when the sides are equal, whenever the sides are equal. Okay, so therefore x is going to be equal to p by 2, y is going to be equal to p by 2. Directly you can solve without differentiation. Therefore the option 1 is going to be the right answer. Here don't go for the differentiation. Directly, previously we have solved one problem, and there we have seen that here xy means product. So product is going to be maximum. Product is going to be maximum whenever x is equal to y. Product is going to be maximum whenever x is equal to y. Therefore you can just see that x equal to y is going to be happen means x is p by 2 as well as y is also p by 2. If I add these two terms, you will get p. If I add these two terms, you will get p. Clear? Therefore p by 2 plus p by 2 equal to p will be the right answer. Clear? Okay. I think from this you can get your answer. That is x is p by 2 and y is p by 2 is the required answer. Okay. So now the minimum value of 3 to the power of x square minus 2 whole square plus 8 is. This is your given function, and they are asking the minimum value of the given function. Minimum value of the given function. Okay. The minimum value of the given function means you have to calculate f dash of x, you have to calculate f double dash of x, then you have to simplify. Okay. So for that, just take f of x, you differentiate it. Before differentiating, take log on both sides because this is exponential function. Okay, this is exponential function. You have to take log on both sides. That will be log of f of x equal to, take log on both sides, so that will be log 3. Okay, x square minus 2 whole square plus 8 log 3. Because you just see, if I apply log on both sides, it will be log of f of x equal to log of 3 to the power of x square minus 2 whole square plus 8. Okay. So here by using log properties, you can take this term here, that means log a to the power of m, that is nothing but m log a. Okay. So log a to the power of m can be written as m log a. So m value is x square minus 2 whole square plus 8 into log 3. So now you have log on both sides. You can differentiating. Now you can differentiate it on both sides. You just know that differentiation on both sides will be what? 1 by f of x into f dash of x. By f of x into f dash of x. Here you can just see this is constant and this is u, that is function. Log 3 I will write as it is. But here differentiation of 8 is 0. Don't worry about that. To differentiate x square minus 2 whole square. If I differentiate x square minus 2 whole square, so that is going to be 2 into x square minus 2, 2 into x square minus 2, and differentiation of x square is 2x. Okay. That will be 1 by f of x into f dash of x, 2 times of x square minus 2 into 2x log 3. Clear? So 2x into 2 is what? 4x you are going to get. No problem. Now for f to be maximum, you just see f dash of x be equal to 0. For f to be maximum, you have to take f dash of x as 0. So equate f dash of x equal to 0. By equating f dash of x equal to 0, log 3 is constant, no problem. So you can get x equal to 0 from 2x equal to 0. Another one is x square minus 2. So for that you will get x equal to plus or minus root 2. You just see the function. Here you just see the function, equate this term to 0, that is 2 times of x square minus 2 2x log 3 equal to 0. This is constant, this will become 0, constant, this will become 0. So remaining with square minus 2 to 2x equal to 0. Therefore square minus 2 equal to 0 or 2x equal to 0. Here you can just see x equal to 0. Here you can just see square will be equal to 2, x will be equal to plus or minus root 2. X will be equal to plus or minus root 2. Okay. So you will get x equal to 0. You get x equal to 0 and x equal to plus or minus root 2. Okay. So now you can use x equal to 0 as well as x equal to plus or minus root 2 in your f of x, and you can identify the what is minimum and what is maximum value. Clear? F of 0 will be 3 to the power of 12. F of plus or minus root 2 will be 3 to the power of 8. In this, the minimum value is what? 3 to the power of 8. The minimum value is 3 to the power of 8. Clear? Okay. So I think everyone have understood this. Please tell me, all of you, if you have understood, no problem. If you have not understood, you can ask the doubts, that I can clarify your doubts and you can go for the problem. The next problem. Okay. So you just see the 8th problem. What is the 8th problem? If f of x equal to x square minus 1 divided by x square plus 1, square minus 1 divided by x square plus 1 for every real number x, then the minimum value of f of x is see this, f of x equal to x square minus 1 divided by x square plus 1 for every real number x, for every real number x, then the minimum value of f of x, the minimum value of f of x is, so they have given the 4 options. One is minus 1, plus 1, 0, 1 by 2. Here you can just see through the solution, that is f of x equal to x square minus 1 divided by x square plus 1, differentiating on both sides with respect to x. So say that it is u by v form. So if I differentiate this, it will be x square plus 1 into 2x minus square minus 1 into 2x divided by x square plus 1 whole square. Okay. So now if I simplify here, you are going to get 2x into x square, that is 2x cube, minus into minus plus 2x into this term. Okay, 2x into x square will be minus 2x cube. Minus 2x cube minus 2x cube will cancel, and the remaining term will be 4x. 4x divided by x square plus 1 whole square. From this you can just see, for f to be maximum, f dash of x, f dash must be equal to 0. So here 4x divided by x square plus 1 whole square, I will take it as 0. 4x will be equal to 0 and x will be also will be equal to 0. Okay. 4x divided by x square plus 1 whole square will be equal to 0. So therefore if I multiply this to 0, it will be 4x equal to 0. And if I simplify this, x is going to be equal to 0. Once you get x equal to 0, the minimum value is what? You just put x value as 0 here. This will become 0. This will become 0. Minus 1 divided by plus 1. So that is nothing but minus 1. Therefore minus 1 is the right answer. Or minus 1 is going to be the right answer for this particular problem. Okay. Very simple problem. you have to be good at differentiation as well as the techniques of maximum and minimum value for the given functions. You must know the techniques of those particular terms. If you know that, everything is going to be very easy. There will be the given function, you have to differentiate it. Once you differentiate, you know the techniques that if f double dash of x is lesser than 0, then the maximum exists. F double dash of x is lesser than 0, minimum exists. Know the tricks, then you just go on simplifying. Let us take the 9th problem. See here, the greatest value of f of x. That means they are asking maximum. The greatest value of f of x is equal to tan inverse x minus 1 by 2 log x defined on 1 by root 3 comma root 3. This is the given interval. In this interval you have to find. Okay. Please be careful. They have given the interval, that is 1 by root 3 comma root 3. In that interval you have to identify what is local maximum and what is local minimum. Clear? So to identify local maximum and local minimum, you follow the steps which I have already given for you. That is, first thing, write f of x. What is f of x here? Tan inverse x minus 1 by 2 log x. You must know the differentiation of tan inverse x, that is 1 by 1 plus x square. You must know the differentiation of log x is, that is 1 by x. Okay. Now you just see by differentiating with respect to x. As I said, differentiation of tan inverse x is 1 by 1 plus x square. Differentiation of log x is 1 by x. For maximum and minimum, we have to take f dash of x equal to 0. That means 1 by 1 plus x square minus 1 by 2x must be equal to 0. So now you take LCM and simplify it. See here, 1 by x square minus 1 by 2x equal to 0. You take this equation, take LCM and simplify. That will be 1 by 1 plus x square. Here you take LCM, that is 2x minus 1 minus x square divided by 2x into 1 plus x square. Okay, you just simplify it and you are going to get 1 by 1 plus x square. Clear? This is your given function. Okay, so now if I go on simplifying this, it will be square minus 2x plus 1 equal to 0. Square minus 2x plus 1 equal to 0. Clear? That means you have to differentiate the given function. You have to simplify it. Get this equation, you take this term to LHS. That will be 1 by 1 plus x square equal to 1 by 2x. So now take cross multiplication and simplify. That will be x square minus 2x plus 1 equal to 0. If you simplify this, you can just see that x minus 1 equal to minus 1 whole square equal to 0 will give you the required solution, so that x will be equal to 1. Okay, x will be equal to 1. So if I take x equal to 1, if I take x equal to 1 in the given function, you can just see that maximum value will be tan inverse of 1 by root 3 minus 1 by 2 log of 1 by root 3, comma tan inverse of 1 minus 1 by 2 log of 1, comma tan inverse of root 3 minus 1 by 2 log root 3. Okay, the maximum value of this 3 is going to be your answer. Is maximum is pi by 6 plus 1 by 4 log 3, comma pi by 4 pi by 3 minus 1 by 4 log 3. Okay, here the greatest value is pi by 6 plus 1 by 4 log 3. This is going to be your maximum value. Okay, out of this 3. So here you have to be very good at differentiation. Once you are good at differentiation, you can solve x square minus 2x plus equal to 0, so that you are going to get x equal to 1. Once you get x equal to 1, you see the given function. Okay, you see the given function, that is tan inverse of x 1 by 2 log x. You have 1 by root 3 root 3. So 1 by root 3 root 3. In between you have 1. Okay. So for that you have to check for all three values, for 1 by root 3, for 1, for root 3. For all these three you have to check. So that's why you get three terms. That's why you get three terms. One is for 1 by root 3, another one is for root 3, another one is for f of 1. Because you are solving it for 1 by root 3 comma root 3, we got x equal to 1, which is in between 1 by root 3 and root 3. You have to check for all three terms. So put first 1 by root 3, put 1, put root 3. For these three terms, you will get pi by 6 plus 1 by 4 log 3, pi by 4. The third term is pi by 3 minus 1 by 4 log 3. In this three terms, pi by 6 plus 1 by 4 log 3 is the maximum answer. Okay. Therefore, this is going to be the maximum at x equal to 1 by root 3. At x equal to 1 by root 3. Clear? Okay. We can move for the next problem, that is just see this, the dimensions of the rectangle of the perimeter 36 centimeter, that means P is equal to 36 centimeters, which will sweep out a volume as large as possible. Will take the volume as large as possible when revolved about one of its sides are. Okay. So there is a rectangle, perimeter 36 centimeters, which will sweep out a volume as large as possible when it revolved about one of its sides are. What they are asking: is it 10, 8, is it 8, 4, is it 12, 6, is it 4, 4? For that you just say the dimensions of the rectangle of perimeter B, x, y. I will take the dimensions of the rectangle as x and y. Once I take the dimensions of the rectangle as x, y, we know that 2 times of x plus y is equal to perimeter. Therefore, that is 2x plus 2y is equal to 36. X plus y is equal to 36. Therefore, x plus y is equal to 8 and y is equal to 8 minus x. And we know the volume formula. We know the volume formula, that is pi x square y. Pi x square y. See here, this is important. That is, when revolved about one of its sides, sweep out is as cylinder. So whenever you revolve the cube, whenever you revolve the rectangle, it will form cylinder. It will form cylinder whose radius is x. The height is y. Okay. Whose radius is x and height is y. This is going to be very, very important. Whenever the rectangle is going to be revolved, it is going to form an cylinder. It is going to be form an cylinder with x as radius and y as the height. Okay. So now volume will be equal to pi x square y. X is radius, y is height. So it will be y as 18 minus x. Here you can just see pi is constant term, and x square 18 minus x you are going to get. Clear? Okay. Just see the next step, that is by differentiating. By differentiating, we are going to get pi is the constant term. Here this is u, this is v. Square I will write as it is. I will differentiate 18 minus x, so you will get minus 1. I will write 18 minus x as it is, and I will differentiate x square, it will be 2x. Therefore, this is your first derivative. So now equate that term equal to 0. That means you have to take the first derivative as equal to 0. You have to take the first derivative as equal to 0. So see, you are going to get x into 36 minus 3x equal to 0. Here once you will get x equal to 0, and another one you will get x equal to 12. To simplify 36 minus 3x equal to 0, you will get x equal to 12. X equal to 0 is not possible because radius cannot be 0. Radius cannot be 0. So therefore, 3x is equal to 36 and x will be equal to 12. Once if you take x equal to 12, y will be equal to 6. Okay. X equal to 12 and y is equal to 6. The required answer. Clear? That is your option is equal to 12 and y is equal to 6. This x equal to 12 and y equal to 6 will be your answer. Clear? Okay. Now quickly we can move for the next problem, that is problem number 11. See that the sides of a rectangle of greatest area which can be inscribed into an ellipse. This is the given ellipse. The sides of rectangle of the greatest area which can be inscribed in the ellipse. That means there is an ellipse like this, and they are putting rectangle inside this ellipse, and the maximum area of this rectangle is what? Okay. At that maximum area of rectangle, what is x and what is y they are asking. What is x and what is y they are asking. Very beautiful question. Okay. You just say ellipse is x square by a square plus y square by b square equal to 1. You just say the sides of rectangle of a greatest area which can be inscribed into a ellipse square by a square plus y square by b square is given by root 2a and root 2b. Root 2a and root 2b. These two are the important things. Okay. So now here you can just see a square is 25. B square is 9. A square is 25, b square is 9. A will be 5, b will be 3. A will be 5, b will be 3. 5 root 2 plus 3 root 2 will be the required answer. 5 root 2 see this 5 root 2 and 3 root 2 will be our required answer. Okay. So here the important thing is what is the value for what? Your maximum rectangle. Maximum rectangle means the values of greatest area of rectangle. The values of greatest area of rectangle, that is root 2a comma root 2b. This is the ellipse. Root 2a and root 2b are going to be the values for the greatest area for a rectangle which can be inscribed. See this? This is the ellipse. Put inside the ellipse here if this is maximum area, then root 2a and root 2b. Root 2a and root 2b will be the values. Root 2a and root 2b will be the values. Okay. Therefore, you have to find the values of a and b. Find the values of a and b. You just see this is a square, this is b square. A value will be 5, b value will be 3. So whenever you have root 2a and root 2b, you can have a maximum area for the rectangle which can be inscribed inside the ellipse. Therefore, you can use this to as very important point. If root 2, 3 root 2 will be the answers for your 11th question. Okay, that is option 3 is going to be the right answer. Option 3 is going to be the right answer. Okay, students. So I think all of your problems are clear to you. Yesterday we have solved the problems of increasing and decreasing. Today we have solved the problems of maximum and minimum. So please go through that problems and you can also understand them. If you have not understood, you can again go through them and again you can solve them. Watch the video again and again if you have not understood the problems. Once if you get any doubts, you can ask them. No worries. Okay. So the next class we shall continue with some another chapter and some interesting problems. Let us meet the next session. That will be after 2 days. Okay. So therefore, thank you everyone and follow the classes and prepare good for your CET exams.